Hi everybody. Let's take a quick overview of assembly procedures. Now a lot of this is going to be intuitive based on your high-level language experience because things are not much different from how things work in high-level language. This shouldn't be a great surprise when you stop to think that anything written in a high-level language has to ultimately translate to assembly somehow. Just keep that in mind. So all the programs you've written had main as a procedure in there. Please remind yourself, main is just a procedure, but a special one. Just like in C++, C, Java, you can write an entire program just using main, but it's better to break things up into procedures or functions. It acts like the driver and calls other procedures. Now for all procedures other than main, got to keep a couple of things in mind. First of all, those procedures must end with the return instruction, the RET. And you might wonder, well, what happens if I forget that? I can tell you right now, nothing good happens, because what's going to occur in your program is it's just going to continue on to the next instruction after the RET, which is probably going to be in another procedure below the one where you forgot the RET. It's sort of like leaving out the break in a switch statement. And don't forget, any procedure can call another procedure. So you can have what's called nested procedures. Now for any procedure that you write, please put a comment above it that contains some information. First of all, a description of what this procedure does. Next, what inputs, in other words, what parameters this procedure is going to be receiving. Then tell what it's going to return. Usually that's going to be in the form of storing a value in a register. And then make sure you mention any preconditions. For instance, if you were writing a procedure to find the square root of a number, one of the preconditions would be that the parameter is at least as big as 0. You don't want to try and find the square root of a negative number. Inside the procedure, you're going to put labels, and those labels are going to act like just local markers. They're only visible inside that procedure, and keep in mind, they're not variables, they're just names for locations inside a procedure. All right, let's take a look at how this is going to work. I've got main, which is a procedure. It's going to call another procedure named addNums. To make it easier to follow what's going on, I'm adding some just made-up numbers over here on the left. The numbers in blue represent the addresses of instructions in main and in the addNums procedure. In real life, these would be huge numbers. This is just going to make it easy to follow. So pretending right now that I'm executing whatever instruction is on line 30, that means the instruction pointer is going to be at 35, because the instruction pointer always contains the address of the next instruction that's going to execute. So we go there. Notice the instruction pointer goes to 38, which will be the address of the next instruction that will execute in main. But now I'm going to call a function call. So what has to happen? I've got to keep that 38 in the instruction pointer somewhere so I'll know where to come back to when the addNums procedure ends. So the logical place to put it is on the stack. That's what automatically happens when you make a procedure or function call. It stores the address that was in the instruction pointer on the stack. So that's why you see 38 there. All right, now the next thing that happens is we're going to be jumping down to that 56, the address of the first instruction in the addNums procedure. So that means the instruction pointer changes to 56. And we go there. Notice the instruction pointer now looks at 60 as the next instruction to happen. Eventually, it's going to get to this 84, which is the return. Now, what's going to be the next instruction? When the assembler sees that return, it knows its next instruction will be at the address at the top of the stack. In other words, that 38. It automatically pops that 38 off back up here to the instruction pointer, which means now then the next line of code that's going to execute is 38. Notice the instruction pointer goes to 44 because that'll be the next instruction that will happen in main. and then the program can end or whatever's going to happen. But anyway, that's just an idea of how all of this works. There's a more detailed look at it in the other video that I made for y'all. Now, how do you return values when that procedure ends? Here's the way most code does it. If it's an 8-bit value, you return it in the AL register. That's an 8-bit register. If you're going to return a 16-bit value, put it in AX. And as you might guess, if you're going to return a 32-bit value, put it in EAX. And here's just a few more things to remember. First of all, inside a procedure, don't directly refer to data that exists outside of that procedure. It's okay to refer to constants, just don't refer to data. Another thing, use general purpose registers to send parameters as either addresses of some data that exists outside the procedure or a copy of data that exists outside that procedure. Now we're going to amend this a little bit later on, but let's stay with this for right now. Any registers you're going to use in the procedure, go ahead and push them on the stack and then pop them in reverse order right before you make the return instruction. If you use the uses operator, it automatically pushes the registers that you're going to use in that procedure for you. All you have to do is just list them. And finally, make sure that you don't push a register that you're going to be using for a return of some sort. So don't push EAX or AX if you're going to be returning a value in those two or in the AL register. If you do, you'll be throwing away your return value. That pretty well covers the highlights of how to make procedures work in assembly. Make sure you get with me if you got questions, and I appreciate you watching.